Good morning, Year 4. Welcome to the first lesson of this week. And this week we're going to be looking at fractions. So I'd like you to start with the mental arithmetic challenge if you'd like to answer the questions on the screen, and pause the video now. Welcome back, Year 4. I'm now going to reveal the answers so you can mark them. Now, the objective is very similar to last week, but we're going to be dealing a lot more with 4-digit numbers now. However, if I'm subtracting 400 from 1061, I'm going to get the answer 661. And I know this because of my number bonds. I know that 6 added to 4 will make 10. And equally 600 add 400 will make 1000. And I very much hope that when you're completing the questions, you are just doing that little check mentally using the inverse. That's probably one of the most important things you can do, is develop a really good habit of when you've done a math calculation, just a quick mental look at it, just to check that actually I can see it's definitely right. And using the inverse is a really good way to do that. Now, if I was going to be subtracting 300 from 1245, I know my answer is going to be 900 and something, because effectively 12 lots of 100 subtract 300 is 900, or 1200 subtract 300 is 900. And similar to last week, because I've got 45 in the tens and ones column, but I haven't got anything in the tens and ones column here, my 45 will remain. So, on to today's lesson. We're going to be looking at trying to recognise equivalent fractions. Now, we've had at least a couple of weeks on fractions in the autumn term. You've done a lot of work on fractions in Year 3 and Year 2 and Year 1. So we are familiar with what fractions mean. However, it's this understanding of the word equivalent, which effectively means the same. So we're going to be looking at fractions that are the same amount, the equivalent amount. We're going to be recognising and writing these fractions, and I'd like you to think today about the fact that a quarter is going to mean 1 in every 4. 3/4 would mean 3 in every 4, and I'm going to keep referring to that within the input. My last point before we start is we have actually done equivalent fractions in the autumn term as well. So this isn't new to any of us, but we're going to build on our skills and refresh our skills. So first of all, we've got a question that says the same strip of paper has been folded in different ways. I can see it's the same strip of paper because the length of it is exactly the same and the width of it is exactly the same on strip A and strip B and strip C. So we've got to match the strip to the correct fraction. I'd like you to pause the video now and decide which fraction is A, B or C. Thank you. So we can clearly see that A shows a half. That's a very simple fraction that we learn from very early on in our education. And also it's important to remember that it means 1 for every 2 parts. 1 in every 2. B, I can see that I've got 2 for every 4. So there are 4 parts in total and I've got 2 coloured. My answer is 2/4. And finally, I can see that I've got 4 coloured, 4 for every 8 parts. Therefore, I have got what is known as 4/8. And just a reminder that the amount of parts it's cut into. So here we've got 1 part, and then we've got a second part, that our denominator shows how much the fraction is cut into in total. I've obviously, as I've already said, got 1 part out of 2, 1 for every 2 parts. Now, if we have a look at these 2 fractions then, my question to you is, are these fractions equivalent? What does this mean? If you were sharp with your listening, you'd have heard earlier that I said that equivalent means that the fractions are the same amount. If I just said they're the same, sometimes people can find that a little bit confusing because they say, well, they're not exactly the same. This one is 1 for every 3, it's showing 1/3. And this is showing 3 for every 9. It's showing 3 out of 9 is showing 3/9. But actually, the same amount means that the size of this fraction that's blue in this bar and the size of the fraction that is blue in this bar is the same amount. If these were 2 cakes, I'd cut my first cake into thirds. My second cake I'd cut into ninths or 9 pieces. If I ate 3 out of the 9, or I ate 1 out of my 3 pieces, effectively I've eaten the same amount of cake. I've eaten an equivalent amount. So true or false? Shouldn't be too difficult, this question. The shaded images, in other words the parts in blue, represent equivalent fractions. Hopefully everyone straight away thought false. We can clearly see that this bar has got more shaded. There's a larger amount of this bar that is shaded blue than in this bar. Therefore, they're not the same amount. This fraction is showing 1, 2, 3, 4, 5, 6 parts, and this fraction is 4 out of those 6, 4 for every 6. So I've got 4/6. And in this fraction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 8 blue pieces coloured out of 10, 8 for every 10. So 4/6 is not equivalent to 8/10. How can I prove it? Well, I guess if I had a piece of paper and I cut both of these out, I could lay this bar on top of this one, and I could clearly see if I was to fold it along this line, that actually this amount it would not have gone along the bar as much as this amount. So laying them on top of each other would be one way that I could prove that. Now, do these images show equivalent fractions? Well, hopefully straight away you've seen that this one is not equivalent. This one is with this one. And although they're far apart, if I was to put a ruler or a line and show where I could cut these bars, I can see that this amount here is the same as this amount here. They're equivalent to each other. So I can therefore write down that 4/6, which is what this fraction shows, okay, 4 parts out of my total of 6, that is equivalent to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this bar has been cut into 12, so there's my denominator. And my numerator, which tells me the amount that is blue, I can see that 4 is left, so 12 take away 4 is going to give me 8. So I can see that 4/6 and 8/12 are actually the same amount of a bar. They are equivalent. However, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as we said earlier, 8/10 is not equivalent to these two fractions here. Now, as well as thinking about equivalent fractions in bars, you're also going to need to be able to shade shapes today. Now, I would say that the very first shape here, very easy to shade a quarter. Now, what's very difficult for me on this whiteboard is to colour all of this equilateral triangle without coming out the lines, and you're going to have to spend a long time watching me just colour. So I think we can cope for the input with myself just colouring a part of a fraction, but you recognising that I should have actually coloured all of that triangle. But again, I've coloured 1 for every 4. 1, 2, 3, 4. So I've coloured 1 quarter. If I look at the cross down the bottom, again, not too dissimilar. I could colour this part And again, I've coloured one piece out of 4, one for every 4. I've got 4 parts, I'm colouring one of them. But these two shapes, it starts to get a little bit more tricky unless you continue to think of this fraction as 1 for every 4. So this shape has got 8 parts to it. Some of you have probably already worked out that 2/8 is what I need to colour 2 pieces out of 8. But if you were struggling to see that, if you think of your shape in sections of 4, here I've got 4 sections, okay, so this half the shape has been cut into 4, so I would colour 1 for every 4, one of those 4 pieces. And then in my second part, which again is my second half has been cut into 4 pieces, I could colour any one of those, and I'm going to colour this one. So I've now coloured a quarter of this shape, and if I get rid of that line, we don't actually need that. This is actually showing 1/4, but it's not maybe how we normally think that we would see it. Actually, if I just use my rubber for a second, possibly most of us would have expected me to have coloured the shape here, because if I make a cut down here and across here, that's probably how I'm more familiar to seeing a quarter. Okay, I've created 4 parts, if you like, of this circle, but actually it's still 1 coloured for every 4, and we've still got 2/8 that are actually coloured. So 1/4 is the same as 2/8. Now the final one down here then, so we've got 6 pieces across the top, same at the bottom, therefore I'm dealing with 12ths. I could actually write that my denominator is 12 because I've got 12 parts out of the whole bar. Now we're going to show 1 for every 4. So again, I could colour 1 for this 4. For let's say this 4 here, I could colour another one, and then for this 4 here, I could colour another one. So actually 3/12, 3 for every 12 is the same as 1 for every 4. Just in case you can't see how I've split that into the 4 pieces each time, here we can see that I'm thinking of 1 for every 4. And if I was to divide the cake up like this, here I can see 1 for every 4 and 1 for every 4 down here. Now, some of you, not so much the bronze and sapphire challenges, but I still think it's good for you to watch this, would need to be showing 3/4 on lots of shapes as well. Now, sapphire and bronze, you will have one like this where actually we know that 3/4 is going to be 1/4, 2/4, 3/4. 3 for every 4. But if I was to take this shape and do 3 for every 4, again I need to see that I've got 4 pieces. I've got 4 pieces, so I could colour it like that if I wanted to. Think about how we cut that cake or cut that circle before, across the middle. And equally I could do 1, 2, this time I might put the 3 together, but I've still got 3 for every 4, 3 for every 4. Okay, so we've already visualised how we cut this hopefully last time. 3 for my 4 pieces here. I'm going to do these 3 for these 4 pieces, and then these here I'm going to colour this one, and this one, and just accept my apologies there for a second. Really important that I don't shade outside the fraction. And if I just cut that to show you again where I was visualizing that in my head. There's my 4 pieces. I've colored 3 for every 4, and here I'm visualizing 3 for every 4 and 3 for every 4 parts just here. So what I've actually shaded here then, there were 12 parts in total, and I've actually shaded 3, 6, 9. So 9 pieces coloured out of 12, 9 for every 12, 9 12s is actually the same as 3 for every 4, 3/4. And at the top here, I can see that I've coloured out of 8, 6. So 6/8 is also equivalent to 3/4. That should be enough information for you to be successful with your task today. So for a slight change today, I'm actually going to be asking anyone who chooses the bronze or the sapphire challenge to do the same thing. Your instructions for task A are here, and you need to colour in some shapes and label them. And your instructions for task B are there, again, colouring in shapes and labelling them. Silver challenge, you have got a series of problems, and then you've got a task B as part of that. And then gold, you've just got a few more shapes to possibly shade. And again, you've got some challenges at the end. Now, if you're doing silver or gold, the answers to the questions are at the bottom. If some of those answers don't fully make sense, your teachers will still be marking this for you, but that might help. But we've not provided answers today for the bronze and sapphire. But please, all of you, think really carefully, does my answer make sense? And keep remembering, 1/3 means 1 in every 3. 2/3 means 2 in every 3. Good luck with your tasks today, Year 4, and look forward to speaking to you again tomorrow. Thank you very much.